In this video, we will take a look at the data structure called stack. When we have a lot of data, we need an efficient way of storing that data. A data structure is nothing but a format in which we store the data. Different data structures store data in different ways. A stack is one such data structure. It stores elements of data Now, the way in which it stores the data is it follows the last in, first out policy. The last element that enters the stack is the first element which is removed from the stack. To understand how a stack behaves, let's look at an example. Let us say a teacher is collecting notebooks. Let's say that person A submits his notebook first. After person A, person B will submit his notebook. After person B, person C submits his notebook. And after person C, person D submits his notebook. Now, when the teacher starts to correct the notebooks, the first notebook that she will take out from the stack and correct will be notebook D. As you can see, the last notebook to be submitted, which is notebook D, is the first notebook which is taken out of the stack for correction. In other words, the last notebook in is the first notebook out. That is what the LIFO, or the last in, first out policy means. Over here, it is important to note that always a notebook which is added to the stack is added to the top of the stack. A notebook is not allowed to be added to the middle of the stack or to the bottom of the stack. It is also important to note that when we remove a notebook from the stack, it can only be removed from the top of the stack. We do not allow notebooks to be removed from the middle or the bottom of the stack. I'm going to repeat that once more. All additions and all deletions occur at one end only. This end is the top of the stack. So where does a structure like this or a protocol like this help us? Now, there are many applications of a stack. A major one being the backtrack operation. So let's take an example of this in where stacks are used in the real world. It is used in internet browsers to perform the backtrack operation. Let us say you are on page A and you are moving to page B. When you are moving from page A to page B, the address of page A will be put into the stack. To not confuse it with this stack, let me take it as page 1, 2, and 3. So once I have moved from page 1 to page 2, page 1 will be pushed into the stack. Now I am on page 2. When I move from page 2 to page 3, page 2 will be pushed into the stack. Now I am on page 3. When I click the back button on my internet browser, what it does is it will remove the topmost element of the stack. When it removes the topmost element from the stack, it will attain the address of page 2. When it removes the address of page 2 from the stack, it will put this address in the URL and we will be redirected to page 2. So, when you are on page 3 and you click the back button, the page 2 URL, which is the topmost element of the stack, will be the page you are redirected to, and that element will no longer exist in the stack. At this point, you will be on page 2 and only page 1 will be part of the stack. Now you are currently on page 2. If you were to click the back button again, the stack will check the topmost element. Now that page 2 has been removed, the topmost element is page 1. You will be redirected to the address of the topmost element of the stack, and that no longer ceases to be the topmost element and it will be removed. Currently, you are on page 1. In this way, we use stack in real life situations. Now I have explained the stack using 2 examples, using notebooks and using internet pages. But in general, a stack can contain a collection of any type of data. Now suppose I want to use a stack in my program. It means I need to create a stack in my program. So let's say I need a stack. So a stack is a collection of data which has a certain behavior. That behavior being the points we have just listed, last in first out and all additions deletions at the top. In any object-oriented programming language, the first thing we will think of is we will create an object because we need to store data and it needs to have a behavior. So let me create the object stack and define its behavior as well. To create an object stack in a programming language, over here I'm using is Java. I'm creating a class stack. So what was the data that we said this object should contain? A stack should contain a collection of data. Now in any programming language, we know that the simplest way to represent a collection of data is through an array. Now this array can be of any data type. It can be of integer, string, or even user defined. For this example, I am going to take the array of the stack to be an integer array. Therefore, this stack is going to contain integer elements only. So now I have an array in my stack. What else had we said about the stack? It is a collection of data in which all additions and all deletions occur at one end called the top. How can we interpret this in the form of an array? The top is nothing but an index in the array. If you consider this A, B, C, D to be an array, it will look something like this. I'm writing down the indexes. The top of the stack is now at D, just as the top of the stack in this case is over here. Now the top represents that index which was the last index to have been filled. Before we had, suppose we have to input another element, say E. E will go above the top. Let's say this array was of 5 elements. When we input E, E will come to the top of the stack and E will now be the new top of the stack. Similarly, when we input E here, the top would have moved to the element E, or rather the top would have moved to the index 4. So what is the top? The top is an integer variable which stores the last index which has been filled in the stack. So that is a variable which we will need to keep track of in the stack. Therefore, that becomes one of our data members in the object. Now the stack has different properties. The stack has a defined length, which is the length of the array used. We could keep that as one of our data members. This is not particularly necessary, but it is good to keep a track of the length of the array. So len or len is going to store the maximum length of the stack. Once again, this is not necessary. You can always get the length of the array by doing arr.length, but this is just to make a few things easier for us throughout the implementation. These are all the data members or the variables you will need in your stack object. Now that we have defined what kind of data we need for the stack, we need to see what behaviors this stack does. Before we look into the behaviors, let's see how we are going to initialize this stack. To initialize any object, we will need a constructor. This constructor is going to have one parameter. This parameter is going to be the length of the array. We are assuming that when the user creates a stack, he will create it along with whatever size he wants the stack to be. So I have a user input len coming to the stack whenever he creates that object. So the first thing I will do is I will initialize the array to the length which the user has given, which is len. After that, my variable of this object len, I am going to initialize it to the user given len. So this .len, which means the object's data member len, should store the value which the user has given in the user given len. After this, I must give a value to the top. Now when the user creates a stack, the stack is empty. Now when the stack is empty, we cannot define the top of the stack. I'm going to keep stack as -1. I'm going to keep top as -1. Now the question arises, why am I doing this? If you remember when I said, whenever we add an element to the stack, we are going to increment the top, so that the top will point to that index which was the index that was last filled by the stack. Now when I enter the first element in the stack, I am going to increment top. When I increment top by 1, top will become 0. Therefore, the first element which is at index 0 will be the last element which was filled into the stack. Also, top being incremented by 1 will go to the 0th position. This is why we are initializing top to -1. We will get a better understanding of this when we see the addition and deletion functions as well. This is all that there is for the initialization of a stack. After this, we will come to the two main operations that a stack must perform. It must perform additions and it must perform deletions. The name we give to the function which performs additions into the stack is push. And the name we give to the function which performs the deletions on the stack is pop.